in the Fulton County Executive Airport. I have Carl on the call with Avcom. He is a senior aviation lighting specialist. Carl Johnson. He will be speaking on LED challenges with airfield lighting. Good morning, Carl.
Good morning. You ready for me to take over?
Yes, sir.
Want to give him a few more minutes?
Maybe we can give him a few more minutes.
All right.
Are you able to share your screen?
I'll look and make sure here. Hopefully you're seeing a slideshow.
We're seeing your notes, Carl.
Okay. See if I can figure out how to swap that then. How about now? You see
Not
me?
not seeing anything right now.
Yeah.
Carl, if you want, I can share. You just let me know when to change over to the next slide.
Well, I have my cheat sheets there when I use them, so let me see what I can get. Back to this and stop sharing.
I think you got it this time.
How's that look?
Much better. That's right.
All right. Now I just have to get my notes back on my other sheet. I think I'm cooking with gas now. So anytime you're ready, I'm ready.
Looks like we're ready to go.
All right.
Ready.
Well, good morning. My name is Carl Johnson, like Jonathan said. And presentation is sponsored by the Georgia Airport Association, and the Georgia Airport Association selected topic and approached Avcon for the presentation. Avcon is a full service engineering firm. We were established in 1988 in Orlando, Florida. The division of serving as aviation consultants, thus the Avcon in our name. Started 4 employees and has grown to now more than 120 dedicated individuals throughout the Southeast. And we pride ourselves on repeat customers. I appreciate the opportunity to present here today. And Jonathan mentioned I'm the Senior Aviation Lighting Specialist with Avcon Incorporated. About 50 years of design, construction, and maintenance of electrical distribution, airfield lighting, and nav aid system experience. And if you're interested in my bios in the training flyer that was distributed, I've got a little disclaimer that I need to make. That I have the privilege of serving on NFPA 780 Technical Committee, UL 96 Standard Technical Committee, the IES RP 37 Aviation Subcommittee, and I'm a AAA ACE instructor. Views and opinions expressed in this program are mine and shall not be construed as an official position of NFPA, UL, IES, or AAAE, and shall not be considered as nor relied upon as a formal interpretation. And my being a part of all those organizations doesn't mean I'm any smarter than you are. It simply means I volunteered. Each of you have unique experiences that would be valuable to these organizations, and I'd like to take this opportunity to attempt to convince each of you to become involved with the writing and updating of our relevant codes and standards. After all, we're the ones who have to live with the results of these codes and standards. We have to implement them in our daily lives. And having a positive effect on the aviation community is one of the Georgia Airport Association stated goals. Your input is critical to their success, and the FAA has an advisory circular feedback page at the back of most of their advisory circulars. And if you'd like, you can start on your inputs today. Dick Holonyak invented the first visible light LED in 1962. LEDs that produce green and blue light were developed in the 70s and 90s respectively. And in the autumn of 96, the first white light LEDs were offered for sale. And white light is obtained by using multiple semiconductors or a layer of light emitting phosphor on the semiconducting device. This graph kind of shows a little history of light sources. See the original Edison's light bulb there on the left in 1879, and used incandescent lights for quite a long time. But incandescent lamps, whether they're quartz or just standard incandescent lamp, are highly inefficient. Anywhere from 92 to 98% of the energy used in the lamp is generated as waste heat. Fluorescent lamps contain mercury, so they're not too good for us in the landfills. And LEDs were able to be made in color. So the first blue taxiway edge light design that I performed was back in 2003, 2004. So they've been around for 2 decades now, pretty easily, and they've performed well. LEDs are semiconductor light sources that combine a P-type semiconductor material, large hole concentration, with an N-type semiconductor, large electron concentration. And when you apply sufficient forward voltage to bias them, the holes and the electrons join and they emit light when they're combined. That falls back into transistor theory, which none of us will probably ever use again. Color light corresponds to the energy of the photons, is determined by the energy required for the electrons to cross the gap of the semiconductor. And again, white light is obtained by using multiple semiconductors or a layer of light emitting phosphor on the semiconductor device. In 2007, Congress passed the Energy Independence and Security Act. And that's how we ended up with the phase out of the incandescent lamps. Inefficient light bulbs were being phased out. It does not ban the use or purchase of incandescent lamps. It does not ban the sale or manufacture of all incandescent bulbs, just those common household incandescent and other bulbs that are not energy efficient. The act requires about 25% greater efficiency in the lamps than what we have or what we had when the 2007 Act was put into place. That's traditionally for the 40 to 100 watt lamps that we use in our home and business. Many bulbs, including specialty lamps, three-way bulbs, refrigerator bulbs, plant grow lights, and our taxiway and runway incandescent lamps, are exempt from the law's requirements. As of August 1st, 2023, Department of Energy is codifying in the CFR that the level of lumens per watt will be 45 lumens per watt, which is a significant improvement over what we did have before. Lumens is a means of measuring the amount of light out of a device. Lighting used to account for the largest share of electricity consumption in the US. In the commercial buildings in 2003, lighting accounted for 38% of the energy usage. And because of improvements in efficient lighting, it dropped to 17% of the electrical load by 2017. Incandescent lamp manufacturers are still committed to make the specialty lamps like the quartz lamp, the T10 lamp you see on this slide. Lamps are manufactured in batches, and a manufacturer may make batch 1 is be 30 watt lamps, and batch 2 may be 200 watt quartz lamps, batch 3 may be a 45 watt quartz free focus. Manufacturers got to make a certain number of lamps in order to be cost effective. So let's say they've got to make 100,000 lamps of this one particular type in order for them to be cost effective on their run. They're going to sit on orders until they get enough to make it cost effective for them to manufacture this run of lamps. They make a few extra lamps based upon market projection, but again, any product they've got on their shelves is money that they're not, it's not making money for them. So stored materials is not a money-making objective they have. So basically, there's not a large enough market for LP lighting bulbs to support the lamp manufacturers. This is a picture of the GE factory in Columbus, Ohio that closed in 2017 simply because they weren't making enough money. The priority is for the lamps that have the highest volume of sales. That's going to be their first priority. The FAA Advisory Circular 150, 5345, 53D is titled Airport Lighting Equipment Certification Program. You'll see it referred to as ALECP. It describes how an organization can get FAA acceptance as a third-party certification body and how manufacturers may get their airfield lighting equipment qualified under the program. But typically, they have to recertify something every 7 to 8 years. So once a product is manufactured, the airfield lighting equipment manufacturer must provide units to the third-party certifier to be tested to ensure they comply with the FAA guidance and criteria. Once an equipment type has been certified, the manufacturer may not make any changes to the equipment without submission of the changes to and recertification by the third-party certification body. There are currently 2 third-party certification bodies, Intertech Testing Services and Elite Electronic Engineering. Now, the font here is a little bit small and a little bit difficult to read. This is one of the pages out of the addendum for the approved airport lighting equipment certification program. And here on the left side of the column, you'll see it says Airport Lighting Company. That's the manufacturer. The fixture type is an LH61, which would be a medium intensity edge light. Mode 1 means it is current driven. And over here on the right-hand side are the catalog numbers for that particular fixture. And then in parentheses is the lamp number. And in order for that light to be certified, you've got to use this lamp number, 725. You scroll down a little bit further, you'll see the same thing with LH61 with an L in parentheses. That's an LED fixture. And there you got the part number and the brackets with the LED part number. In order to maintain certification, these fixtures have to have the proper lamps used in them. So this list is provided to assist airport sponsors in discharging their duty to determine that equipment met the applicable FAA specification, which is required for eligibility for funding under federal grant assistance program. So in order to comply with funding requirements from the FAA, you've got to use equipment listed in this addendum. You want to verify that your equipment is on this list. This is the only way you can determine that the light fixture itself meets the requirements of the FAA. And this is just a partial listing. There are 52 pages in the current addendum that list approved equipment and light sources. I spoke with 4 fixture manufacturers in order to prepare this presentation, and only one manufacturer had plans to recertify their incandescent fixtures once they expire. And this particular manufacturer had a strong military clientele that needed the IR signal from the incandescent fixtures. Remember, I mentioned earlier that 92 to 98% of the energy is wasted in heat. In this particular case, it's not wasted because the enhanced vision systems see this heat and the pilots use it for operating their aircraft. Now, I do know that other manufacturers are working with solid state IR emitters. Now, this form on the right side of the screen here is certificate of conformance from the Intertech testing laboratory for airport lighting equipment. And this happens to be an ADV unit. That's the LH61 fixture. And you can see here the original issue date was January 9, 2018. Recertification date is due January 2025. ADB has issued a product discontinuation notice. Says ADB Safegate will cease production of incandescent airfield ground lighting for taxiway applications on June 30, 2024. They'll continue to sell spare parts and honor specific commitments involving these products beyond the phase-out date. And 31 December 2028 is their spare parts support end. So we're going to see the end of the incandescent fixtures. In the year 2000, all the lamps listed in the advisory circular appendix, one I just showed you with the lamp list in it, all of the lamps listed in there were either incandescent lamps or xenon flash tubes for the approach light flashers. There were no LEDs in there. Now the airport lighting equipment certification program has about 3 pages of incandescent lamps that are left and 15 pages of LED light sources. Incandescent lamps are going the way of submarines with screen doors. And I thought this was a pretty good quote for it right here. So most of us can read the writing on the wall. We just assume it's addressed to someone else. The LED advantages. LEDs emit more lumens per watt than incandescent lamps. It means they're more efficient. LEDs can emit light of an intended color without using any color filters. The color filters used to absorb some of the light energy, so it took more light energy, more electrical energy to provide it. to get the proper light out of the fixture because of what was absorbed by the filters or the lenses. So it's more efficient to use the LEDs because the color is correct to start with. LEDs are very small and are easily attached to printed circuit boards. LEDs are ideal for uses subject to frequent on-off cycling. Unlike incandescent fluorescent lamps that fail faster when they're cycled, or high-intensity discharge lamps that have a cool-down period before they'll restrike and go to full output. LEDs can very easily be dimmed either by pulse width modulation or lowering the forward current. LEDs have a relatively long life. They mainly fail by dimming over time rather than the abrupt failure of incandescent lamps. LEDs being solid state components are difficult to damage due to shock. And engineering brief number 67 says light sources other than incandescent xenon for airport and obstruction lighting fixtures require significant internal surge protection. So the FAA criteria for manufacturing of LED fixtures requires a pretty good system of surge protection internal to the fixture. I will tell you that new fixture installations should include equal potential counterpoise, lightning protection system, and field lightning arresters. Field lightning arresters are basically lightning arresters very similar to the arresters that the FAA mandates on the output of a constant current regulator, except they're designed to be installed in the light bases. The LED disadvantages: performance largely depends on ambient temperature. LEDs are very heat sensitive, but with the proper design and heat sinks installed, they work quite well for airfield lighting fixtures. And the efficiency of LED decreases as electric current increases. If you increase electric current, that increases heat, so that's also an issue. But again, the designs today are pretty good designs, and they seem to last for quite a while. Color rendition may not be good depending on the LED design, but the LED colors are quite sharp. So the ones in airfield lighting fixtures don't seem to have this problem. The advantages far outweigh the disadvantages for LEDs. Cost. In the early 2000s, cost was very significant. We ended up doing a project for a large airport where we were putting in taxiway center lines and taxiway edge lights LEDs in 2004. In order to do that, we had to generate a life cycle cost analysis to justify to the FAA why they should be paying more for these fixtures than what the quartz incandescent would have cost them. And the life cycle cost analysis was able to demonstrate that over a 20-year period, the airport would save roughly about $100,000 over 20 years for using LEDs versus the quartz incandescents. I discussed the LEDs with ADB's Perry Suganuma, with Kraus Heinz's Kevin Kelly, with Airport Lighting Company's Eric Locke, and with Huey Phillips' Bruce Miller. And they're all pretty much in agreement that the quantity ordered has a significant impact on price. In 2024, depending upon quantity, the cost of the LED fixture is close to the cost of the incandescent fixtures. If you have an elevated fixture, the LED will cost somewhere between 0.95 to 2 times the incandescent fixture. Again, quantity is significant. An in-pavement fixture cost of LED versus incandescent is 1.2 to 3.0 times the incandescent cost. Incandescent fixtures are going to continue to increase in cost. And one of the vendors I talked to just stated they quoted LED L802 beacon, the main airport beacon. And the LED beacon was actually cheaper than the old HID version. So you're going to continue to see the LED prices coming down. You're going to continue to see the incandescent fixtures going up simply because of parts availability. Availability of these fixtures, how much lead time is involved. For an elevated LED fixture, it ranges from 6 to 10 weeks. And they tell me that 10 weeks seems to be the more realistic. In-pavement LED fixtures range from 8 to 12 weeks. LED signs range from 12 to 14 weeks. I know LumaCurve has a waitlist service that if you have a sign, one sign, that gets whacked by a wayward aircraft or a truck or a mower or something or other, they will promise they will build a sign for you and ship it within 24 hours of your order. And I suspect the other manufacturers, if there's enough of a premium involved, would do the same thing. But typically signs are going to take you from 12 to 14 weeks. Incandescent lamp units, I'm told that have the same lead time as the LED fixtures, provided they can get lamps and or sockets. Apparently sockets are also becoming an issue. LED technology is continuing to improve the lumen per watt efficiency. The fixtures can maintain the correct output with fewer LEDs and less power consumption. I recall one of the earliest reels might have been, it was about the same size of a large screen TV set, had 96 LEDs in it. Nowadays, they're the size of a small laptop, and they're operating, getting the same light output with 24 LEDs. Improvement in LEDs is a continuous process. As new LEDs or solid state components are updated, the older LED diodes or solid state components may not be available. Fixture manufacturers have little control over obsoleted diodes or solid state components used in their fixtures. Solid state components, chips, and LEDs are in a constant state of improvement. Once a chip manufacturer changes their component, the old component may be obsolete. The fixture manufacturer may end up having to redesign for the new component and recertify the fixtures. New solid state devices will obsolete the old, leading to a forced update by the fixture manufacturer. Some of the manufacturers are being proactive with this. We had some issues with some taxiway centerline lights a decade ago, where the LEDs were being updated at such a fast rate, the manufacturers continuously having redesigned the power supply for the LEDs. So they designed what they referred to as a universal LED power supply, in order that as the LEDs were updated, they would not have to change the LED power supply each and every time. So spare parts may not continue to always be readily available, just like the lamps not being available and the sockets not being available. You may not be able to get a diode or a power supply for your unit. One of the manufacturers explained to me like this: they're not truly manufacturers, they're assemblers. In the old days, they manufactured everything from the casting of the fixture to the sockets. They were in fact the manufacturers. Now they purchase the components and assemblies from other vendors. They assemble the fixture, have it tested, and sell it to the airports. If their supplier can no longer get a flux capacitor, then the fixture manufacturer may have to modify their design to recertify their fixture. Thus, replacement parts may become an issue for that specific type of fixture. This is FAA Advisory Circular 150, 5340, 30 Juliet. This design and installation details for airport visual aids, and it describes the design and installation requirements for airfield lighting. And they tell us that the AC is not mandatory, but then they go on, a paragraph later, it says the use of the AC is mandatory if you use FAA funding. It goes on to tell us that all lighting configurations contained in the standard are a means acceptable to the administrator to meet the lighting requirements of Title 14 CFR 139. Now in 30J, or those of us who do airfield lighting design on a regular basis refer to the thing as 30J. Then AC 150, 5340, 30J, it talks about mixing of light source technologies. And the AC tells us that the increasing use of airport light emitting diode fixtures on the air operations area has caused concerns when LED light fixtures are interspersed with their incandescent counterparts. LED light fixtures are essentially monochromatic, aviation-wide is accepted, and may present a difference in perceived color and or brightness than an equivalent glass or plastic filtered incandescent fixture. These differences can potentially distort the visual presentation to a pilot. Therefore, LED light fixtures must not be interspersed with incandescent lights of the same type. It goes on to give us an example in the advisory circular. It says an airport adds an extension to a runway. On the existing runway, the runway centerline light fixtures are incandescent. The airport decides to install LED runway centerline fixtures on the new section of runway and retains the incandescent fixtures on the existing section. The FAA says this interspersion of dissimilar technology is not approved for installation. It goes on to tell us that in addition, defective incandescent fixtures must not be replaced with their LED counterparts. When replacing a defective light fixture, make certain that the replacement uses the same light source technology to maintain a uniform appearance. And it tells us which light LED technology systems are not to be interspersed. First one to give us is guard lights. It tells us each pair of elevated runway guard lights must be the same technology. And for in-pavement lights, do not mix LED with incandescent fixtures in the same bar. So basically you could change out your LEDs or change out your incandescents, make them LEDs one bar at a time so that they're uniform across that intersection. Touchdown zone lights, it's either all LED or all incandescent. Runway edge lights, including threshold, end, and stopway, all LED or all incandescent. Signs per location, you can have LED signs and you can have incandescent signs on your airport. but you cannot co-locate LED signs with incandescent signs. Example, if you had a holding position sign on each side of your taxiway or runway, both of them would be required to be incandescent, or both would be required to be LED. Or if you have a sign array that's too long for one sign and you have two signs sitting next to each other with the same message, they both have to be LED or they both have to be incandescent. Taxiway curb segments, center line and edge. You cannot insert or you cannot mix incandescent LEDs in the middle of a curve or in the, whether it's a center line or whether it's an edge light circuit. And taxiway straight segments, you can't mix or you can't break it at the center line. Excuse me, you can't break it in the middle of the straight segment. You'd have to go to the end where it starts a curve. You have to have a consistent layout of all LEDs or a consistent layout of all incandescents. The entire airport on a taxiway does not need to be changed at the same time. You just need to have clear breakpoints between the technologies. And in my experience, it's best to coordinate that with your local ADO to make sure that they're in agreement with where you're planning to break the system at or change the system from LED to incandescent or vice versa. Approach light systems, all or nothing. Stop bars, all or nothing. One-way center line, all or nothing. Lead on, lead off lights, like you see here, it's all or nothing. And your PAPI would all have to be all LED or all incandescent. In this presentation, I'm talking about lamp life and lamp source life. I use them interchangeably. It's the amount of life that your light producing device is going to have. Incandescent lamps typically have 500 to 2,000 hours at 6.6 amps. If you drop the current down, they'll last quite a bit longer at lower levels. LEDs at the neighborhood hardware store are advertised with a 20-year life, simply install and forget. The 20-year life, simply install and forget, should have been prefixed with a once upon a time. Now, lamp manufacturers have what they refer to as an average rated life. That's how long it takes for half the light bulbs in a test batch to fail, half-life. For example, if you're testing 100 bulbs and they're tested and they've got an average rated life of 1,000 hours, 50 of the bulbs died within the test time when it reached 1,000 hours. Some bulbs may have failed within the first 50 hours, some within 450 hours, some within 700 hours, but half were dead within 1,000 hours. That means you got a 1,000-hour life. In Advisory Circular 150, 5345, 53D, Appendix 5, which is our airport lighting equipment certification program, has a lamp life test procedure which differs significantly from above. It's an as installed condition. In order to have a lifetime for the light source on the catalog cut sheet, it runs the third-party certifier runs a test that actually duplicates what it would be in service. So it takes the light device, the light source, puts it in the fixture, and then evaluates it under actual in-service conditions. And that's the AC lamp life test, is lamp life we would see on the manufacturer's catalog pages. So it's actually an in-service, it's a realistic value of the light source. An engineering brief 67D tells us that all LED light fixtures, with the exception of obstruction lighting, must be warranted by the manufacturer for a minimum of 4 years after date of installation, inclusive of all electronics. So your fixtures are guaranteed to have a 4-year life, provided that they weren't run over by a truck or a wayward airplane, or you didn't have a lightning strike. So the lamp life on the manufacturer's brochure should be a realistic value of the life of the light source when you purchase your LED fixtures. Gwinnett DOT has a proactive program to replace LED traffic signal heads on a 7-year cycle. Manufacturer states that the life of the unit is 7 years, so Gwinnett DOT seeks capital funding to replace 1/7 of their traffic signal heads every year. And obviously, they also replace any early failures on an as-needed basis. So that's an idea that you might put forward and might think about for your maintenance on your LED fixtures. Advisory Circular 150, 5340, 26C, maintenance of airport visual aid facilities. This is advisory circular, talks about how to perform maintenance on all of your airfield lighting electrical equipment. Along with that, the Airport Cooperative Research Program, Report 138, is a 2-volume set on preventative maintenance in general aviation airports. And then there's additional ACRP Report 148, and it talks about LED airfield lighting system operation and maintenance. These two publications are available at trb.org, and all the FAA advisory circulars I've mentioned so far are available at the FAA.gov website. LED maintenance is very similar to the incandescent fixture. You want to keep the fixture lens clean. You want to keep the fixture interior dry. Normally, when you have a little fountain like that on a low-lying fixture, you're going to have water up in the fixture itself. In this particular instance, you can see that the light was in fact actually energized and operating. This is table 5-5 out of the advisory circular 150-5340-26C, preventative maintenance inspection schedule for runway and taxiway elevated edge lights. And it goes through what the FAA thinks your inspection should be daily, weekly, monthly, and so on for an elevated fixture. Now, you'd also want to use this as well as any of the manufacturer's recommendations. Typically, what I see is failure rates for LED fixtures is this fixture on the left is in the tidal area at Naval Air Station Key West. And obviously the yellow paint on the fixture itself and the corrosion is pretty bad there. The fixture in the middle is from a wayward aircraft or a vehicle. And the fixture on the right is subject to bird deposits, jet blast on the lens. You want to make sure that the lenses are clean and operational. And as well as it's very difficult for the mowers to get around this thing the way the grass is growing up over it. Now, when it comes to maintenance of your LED fixtures or even your standard incandescent fixtures, step number one is create an electrically safe work condition. And that's critically important. NFPA 70E, which is electrical safety in the workplace, teaches you how to create an electrically safe work condition. So that's step one. You always want to create an electrically safe work condition. That's another whole topic on itself for a future webinar. You want to keep complete fixtures on hand as spare parts. New projects should include new spare fixtures. And the FAA will fund spare parts for these fixtures in the original project. There are some means to do that in their funding criteria. We recommend that you replace the complete fixture in the field. It's faster. You go out there, simply unbolt it, replace the fixture and transformer, and take care of any repairs or troubleshooting in the shop. Do you want to cannibalize defective fixtures to create working fixtures? Well, if you have several of the older fixtures that parts are not available for, and you can create a working fixture out of it, it might be worth your investment. But you might also want to compare spare parts cost to the cost of a new fixture. Talking with the vendors, the power supply was about $115. LED was about $60. That's $175 in parts. A new fixture is $225. By the time you figure you have to order the parts and you got labor to install it, are you better off with buying a new fixture? You're better off with repairing the old one. Just depends on what your labor costs are and what your parts are. And again, you can cannibalize some of the damaged fixtures and create working fixtures out of them in the shop. And this is an example of complete fixtures kept in stock. And again, it's a picture from NASKW. I had some of those. I just made a trip down there. But the priority I want to make sure that everybody understands here, though, is you want to create an electrically safe work condition. That's step one. And in Article 100 of NFPA 70E, it defines a qualified person. And a qualified person is one who's demonstrated the skills and knowledge related to construction and operation of electrical equipment and installation, has received safety training to identify the hazards and reduce the associated risk. Now, a qualified person has demonstrated their skills to the approving authority, their employer, their supervisor, state licensing, and so on. And we must have the skills and knowledge of the system and ability to recognize and identify the hazards. This webinar does not make you a qualified person. Any electricians here have spent years learning and perfecting their skills. The goal of the webinar is to help you recognize the hazards, allowing you to safely perform the work within your own specific skill set. An unqualified person is a pretty simple definition. It's a person who's not a qualified person. All right, we'll take a look at a little bit of basic series circuit theory. We have our basic series circuit here. Got our constant current regulators, can pump out 6.6 amps through the primary loop and back to the regulator. Let's say, for example, we've got a 120 watt lamp A here, getting 6.6 amps. It's going to drop 18.2 volts. Lamp B happens to be a 45 watt lamp. It's getting 6.6 amps through it because current remains constant throughout the series circuit. It's going to drop 6.8 volts. Now, 30 watt lamp here in position C, 6.6 amps going through it. It's going to drop 4.5 volts. So current remains constant throughout the entire series circuit. Voltage varies with the load. In this particular case, I've got 3 lamps. Total voltage drop is 29.5 volts. Let's say I want to add another lamp to the circuit. That adds another 4.5 volt drop. So going from 29.5, I go to a 34 volt drop. Current remains the same throughout the circuit. So what we want to be able to see here is this is your current, I. R, you can consider your load, and E is the output voltage of your constant current regulator. So if your load increases, the output voltage of your constant current regulator increases. If your load decreases, the output voltage of your constant current regulator decreases. So this, again, is your standard 6.6 amp Airfield lighting series circuit. You got 6.6 amps that leaves the regulator, flows through the primary loop, back to the regulator. All the current that leaves the regulator has to return to that regulator. This is the table from the advisory circular 5340-510H, which is the advisory circular that tells the manufacturer how to manufacture constant current regulators. It also gives us the information on what we need to know for setting the current on our regulators. We have a 1/10 of an amp tolerance for our available range on the constant current output for a 6.6 amp circuit, and 3/10 of an amp tolerance on a 20 amp circuit. Our current is too high, shortens our lamp life, which also has the same impact on the LEDs. And if it's too low, current does not provide proper guidance to the airport or proper guidance to the aircraft. And remember, our airfield lighting system, our signal system, we're providing signals to the pilot to know where he can safely operate his aircraft or her aircraft. So we're back to our constant current regulator and our series circuit. It's not truly a series circuit like we have Christmas tree lights where if you lose one light, they all go out. Airfield lighting has the LA30 isolation transformer, which is right here. And so your primary loop from the regulator goes through the primary coil on the LA30 transformer. The secondary coil on the LA30 transformer is what powers the light. So if there's light open circuits, your primary series circuit, primary circuit is still continuous. Get a little bit better view of it here. The advisory circular for creating or manufacturing isolation transformers 150, 53, 45, 47. And they're called LA30 isolation transformers. LA30 is for our 60 cycle units. And you want to make sure that when you purchase LED fixtures that your isolation transformers match the wattage of your fixture. You get the maximum energy efficiency by having a properly sized LA30 isolation transformer. If they're oversized, they'll still work, but you'll end up wasting a little more energy. So you see here, our primary circuit goes through the primary coil in the transformer. It stays continuous. If we have a light burn out, primary loop is still continuous. This is a secondary circuit in that transformer that opens, but the primary current still works. All the other lights stay on. This is what an LA30 isolation transformer looks like. This is the transformer in the field attached to the fixture. Kirchhoff's current law. We want to make sure that we understand that current takes every available path back to the source. 6.6 amps leaves the regulator, 6.6 amps must return to that regulator. It's not looking to go to ground. It will take whatever path or however many paths possible to get back to that regulator. If you hadn't become part of that path, it will flow through you. We need to make sure that we do not become part of the series lighting circuit. Let's talk about some series circuit characteristics. First, we'll talk about what happens when we get an open primary. All the lights go out. In an open primary, no current flows, the lights are out. Constant current regulator sees open circuit as an increase in load. Constant current regulator will raise the output voltage with the load to try to maintain 6.6 amps of current flow until the constant current regulator reaches the maximum open circuit voltage. It's an overvoltage and it trips the constant current regulator offline. Now, these are the typical operating voltages at 6.6 amps. This is what the open circuit voltage would be on the regulator as the open circuit occurs. Fully loaded 30 kW constant current regulator will operate at 4,545 volts across the output terminals on that regulator. This is your nominal normal voltage. That's why our cables are rated at 5,000 volts. But if you open circuit that regulator will jack the voltage up to 9,000, a little over 9,000 volts, trying to maintain the 6.6 amps. It'll raise that voltage for 2 seconds. If within 2 seconds it does not complete the circuit and get current flowing again, it will shut itself down. Constant current regulator circuit trips are designed to protect the Airfield lighting circuit, not us. The constant current regulator does not care. It's designed to continuously pump 6.6 amps through the load, and it doesn't matter if the load is us or if it's lights. It's going to do its best to continue to pump current. Never open an energized Airfield lighting series circuit. Never open a de-energized Airfield lighting series circuit until it's placed in an electrically safe work condition and you have tested to determine it's de-energized with a properly operating ammeter. You can end up with 9,000 volts on your fingertips. I tried to get video of a live circuit being open, but I couldn't find an engineering intern willing to star in the video. And that's obviously just a joke. Now, the next video you're going to see was taken during testing of a streetlight series circuit, autonomous shutdown device. This was a controlled experiment, and the testing personnel's safety was a primary concern. A warning of do not try this at home is necessary, and it's also redundant. When you see it, you'll know why. The device was designed to detect an arc and shut down the series streetlight circuit. And believe it or not, series streetlight circuits where our Airfield lighting technology came from. Electricians are properly trained in wearing the correct personal protective equipment. You can hear the surprise in electricians' voices about the massive arc generated by the constant current regulator. This is what happens when you open a constant current regulator. That's the arc. You can see it right there. So imagine opening an energized series circuit and having one of that between your two hands. So again, you want to make sure we do not complete the circuit. If a constant current regulator can raise the voltage high enough without tripping the over voltage sensor, CCR will continue to provide power to the circuit. CCR simply thinks that you and I are part of the increased load. We do not want to work on energized circuits. We want to make sure that we do not complete the circuit. And again, the CCR will increase the voltage until it reaches over voltage point by tripping, trying to maintain 6.6 amp current flow. And all kidding aside, on a more serious note, in October, roughly 6 years ago, an Airfield construction electrician was electrocuted in Florida, apparently while holding an open energized Airfield lighting series circuit. Tick tracer, you heard them called voltage sticks, pocket tester, and so on. They work great on a voltage circuit. It could be deadly on an Airfield lighting circuit. Do not use it on Airfield lighting circuit. Our Airfield lighting circuits are ungrounded. This device, in order to work properly, relies on the capacitance between the device, the person holding it, and the earth. It requires some current flow, although it be very low, but it will not pick up all points in the Airfield lighting series circuit. There's a null point in there. So do not rely on these to tell you that the Airfield lighting series circuit is de-energized. Always use a true RMS ammeter to determine if an Airfield lighting circuit is energized or de-energized. So what happens if we get a ground in a circuit at home? You know, we get a boom or a tripped circuit breaker, might hear a pop, see a little bit of smoke. You know, we know to go fix it, figure out what's going on. The output of a constant current regulator is ungrounded. So if we get a single ground on our Airfield lighting series circuit, we don't care. Nothing happens. I mean, we want to get it fixed, but nothing happens as far as the operation of the series circuit. Series circuit will continue to work. Remember earlier I mentioned that all the current that leaves the constant current regulator has to go back to the constant current regulator. Going to ground is not one of its options because it has no way to get from this ground back to the regulator. So all the current's going to continue in the copper wiring, going back to the regulator. It leaves the regulator, has to get back to the regulator. The single ground, there's no path for current to flow. So what happens if we get a second ground in our Airfield lighting series circuit? Well, now we have two grounds. We have a path for current to flow through here, and we have a path for current to flow through here. Depending on the proportion of resistance through this path and resistance through this path, you may end up with these lights going dim. You may end up with the lights going out. But part of the current will flow between the two grounds. Part of the current will flow through the circuit, depending on what the internal resistance those 2 points are. For troubleshooting, the problem is probably between the last two operating fixtures. And you do not want to dig while that circuit is energized. You also want to make sure that you do not become part of that circuit, get between the grounds. If we get a short circuit in an Airfield lighting series circuit, again, the current will split depending on the internal resistance of the short and the internal resistance of the circuit. When you make a comparison, the lights may be out. The current flow will be inversely proportional to the resistance. So the higher the resistance here, you get more current this way. The lower the resistance here, you get more current through the short. Again, the problem is going to be between the last two fixtures that are operating properly. And again, we want to make sure that we do not become part of the Airfield lighting series circuit. It takes 1/10 of an amp through a vital organ to kill us, basically 100 milliamps. And our nominal output current on a constant current regulator, 6.6 amps, is more than enough to be fatal. What happens if we get a shorted output on our circuit with another constant current regulator? Power could be off on this circuit's constant current regulator, and a different constant current regulator could be coupled to your circuit. If the respective circuit's constant current regulator is off and the lights appear on or dim, check the circuit with a true RMS ammeter. Circuit could be coupled to another circuit that is energized. If you turn both CCRs on, the two CCRs will have an argument. I've been in a vault one time where they sat there and argued with each other and vibrated. And it was quite obvious that something was wrong. We've covered some of the basic troubles with Airfield lighting series circuits. Multiple problems may present complex or confusing symptoms. Always check for current flow before opening connectors. Even if you've locked it all out and you've demonstrated that you've got an electrically safe work condition, don't break that connector in the field until you've checked it to ensure you do not have current flow. Advisory Circular 150, 5340, 26C, which is the maintenance advisory circular, will provide additional guidance and help troubleshooting a series circuit. Now, a lot of my supervisors at work are civil engineers. We have project managers, a lot of them are civil engineers, don't do electrical work. And they kid us about series circuits. You know, it's only one wire, Carl, how difficult can it be? So I took this picture and blew it up on 11 by 17 and gave it a caption. It's only one wire, Carl, how difficult can it be? This happens to be a manhole outside a very large electrical vault with about 40 circuits going through it. And you can see the damage from a lightning strike here. And this is how you can have circuits burned together. You get some of them in a manhole like this, you can have issues. Never change lamps on an energized circuit. It could be a primary to secondary short on the LA30 isolation transformer. You could end up with 4,545 volts on your fingertips. Now you can see how close your fingertips are going to be to this lamp socket down here when you're trying to change lamps. Replacing lamps. What I would recommend is you drive the Airfield marking in operative fixtures. Don't touch them, but make a mark on chalk on the pavement or something. Look for excessively bright or inoperative lights. Note any unusual conditions. If you've got a infrared temperature sensor that you can point at, you can check temperature of the base cam and fixtures not operating. It'll be a non-contact. You want to create an electrically safe work condition. Get it locked and tagged. And then just change the whole fixture. Take the other one back to the shop for repairs. Remove the marks on the fixture and restore the circuit to operation. And what I'm talking about with a primary to secondary short, here you see that you've got your primary circuit, you got your lamp, you got your isolation transformer. The isolation transformer is nothing more than a current transformer. It takes 6.6 amps going through the primary and converts it to 6.6 amps in the secondary. If you have a primary to secondary short, it means this line voltage that you get on the output of the regulator could be available right here on this lamp. And since it's 6.6 amps, That lamp is still happy. It's getting the current that it requires to operate. It's going to run along quite well until at some point in time the lamp itself fails. And you go out there with your fingertips and start replacing lamps, and you could put your fingers on 5,000 volts right here. There's no indication of that being a shorted transformer. Lamp burns out, you put your fingertips on it, and you become part of the circuit. In July of 2019, the facilities maintenance specialist was electrocuted at Airfield, Wisconsin Air National Guard Base while simply changing light bulbs on an energized runway circuit. Apparently, they just turned the circuit on and instructed him to go out there and start changing the lamps on any of them that were burned out. And I was not there when this video was taken, so I cannot attest to the proper safety protocols were followed during the work performed in this video. And in my opinion, the circuit should have been off prior to removing the bolts from the base cam. But it's got a primary to secondary short. Primary voltage is on the fixture housing itself. The constant regulator is trying to maintain current flow. Once the last bolt was removed, the constant regulator provides sufficient voltage to arc over through the rubber gasket between the base plate and the base cam. There's a second ground in the system so that current flow can be maintained. So it basically created enough of an arc to burn through the gasket and cause the current to flow between that base plate and the base cam. If you pick up the light, you become part of the path for current to flow. Open circuit voltage is up to 230 volts. You get 230 volts open circuit on a 500 watt L830 isolation transformers. That's going to be normal open circuit voltage. On a 300 watt isolation transformer, normal open circuit voltage is 135 volts. OSHA and NFPA 70E set the de-energization threshold at equal to or greater than 50 volts. Anytime you could be exposed to a potential greater than 50 volts, OSHA and NFPA 70E require you to create an electrically safe work condition. And so even down here at a 100 watt transformer, you've exceeded the 50 volts. And remember, if the primary to secondary short occurs, which is a possibility, you could be seeing 5,000 volts out there. Take this time to plug the IES ALC Fall Technology Meeting. It's the world's premier airfield lighting technology meeting in Charlotte, North Carolina, just hop, skipping the road up there from Georgia. It's a great opportunity to meet other contacts in the airfield lighting industry, and there's a wealth of knowledge at the technology meeting. Monday morning typically starts with the users group, and the user group is made up of airports and airport lighting maintenance personnel. So I would highly recommend the Fall Technology Meeting for IES. It's going to be in Charlotte this year. And Mark Goodacre was going to be on the presentation with me today and sit in and listen. He has some family issue he had to take care of, so he's not here today. But this is Mark and myself's contact information. And if you've got any questions or feedback you might have after we finish presentation, we enjoy talking to people. We learn something new from every person we have the opportunity to speak with. So please do not hesitate to call or shoot us an email. We may not know the answer, but we'll try to get an answer for you, and we can all learn together. Mark and I have been doing airfield lighting and nav aids for a long time. We have a lot of contacts. We also have a lot of contacts. Garth Brooks, Mark and I all have friends in low places. So I would encourage each of you to share your contact information with others in the webinar. There's a lot of valuable experience here today. Get your airfield lighting networking started. Now it's time for a quiz. So I guess I'll end my part of it and see what questions you've got. Hopefully you're all still there because I haven't seen anything. Yep.
Thanks, Carl. We're going to open it up for questions and any comments. Does anybody have any?
You're making it too easy on me.
Wonderful. Well, thank you, Carl. This was a great presentation on airfield lighting. A lot of safety related stuff, which is always nice to hear.
I'm not sure how the handouts that I it emailed up a PDF of some handouts of the slides and stuff. They'll have the contact information in it, if they can download it from your website, or how that would work.
I believe a follow-up email after this with the recording with those handouts
Okay.
will go out.
And again, if you got questions, you can give me a call afterwards. I get a lot of the nonsense calls on my cell phone. So if you do call and I don't answer, please leave a voicemail and I'll call you back.
All right. Well, thank you, Carl. There's no questions. We'll go ahead and conclude. Thank you, everybody, for joining.
Thank you. Have a great day.